In this video, we're carrying on with the worksheet. We're going to prove that the left-hand side is equal to the right-hand side. Now, when you see a proof, don't get upset about it. Don't think it's more difficult. It's actually easier because you have the answer on the right-hand side. So all you have to do is work with the left-hand side. And when your answer is the same as the right-hand side, this means you're correct. It's a bonus. So here we're going to have to use the reciprocal function. Notice we have cot x. Cot x is the same as 1 over tan x. Times that by cos x. Now at this point, the only way you can solve further, if you look at it nicely, is that 1 over tan x. That's the only thing that you can really change to something else. So what can that become? The tan x. Think about trig identities. Right, don't forget that tan is equal to sine over cos. Where tan x is, we can substitute sine x over cos x. Notice that this is another way of writing it to the minus 1. So if you punch that into your calculator, if you had to use numbers, for example, you in sine 30 over cos 30 to the minus 1, it would actually flip the numerator and the denominator around. Notice that cos x will now be in the numerator, sine x will now be in the denominator. We can now multiply cos x times cos x, which will give us cos x squared. We also have to find the LCD between the left term and the right term. Notice that the sine x is over 1. So if the LCD is sine x, this means I'll have to multiply the first term by sine x. Multiplying sine x times sine x, we'll get sine squared x plus cos squared x over sine x. Trig identities, sine squared x plus cos squared x is equal to 1. 1 over sine x. So notice 1 over sine x is cos x. Therefore the left hand side is equal to the right hand side. Here's another one to prove. Why don't you pause the video, try it out, and then look at the solution. In this one, we should focus on tan x. Tan x is a identity. So tan is equal to sine over cos. Would that be the perfect item to change? Because notice on the right hand side, we have cos x in the denominator. Now when adding, we need the same denominator. So this would work out perfectly to our favor. Okay, so squaring a binomial, we square the first term and then we square the last term. Pause the video and attempt squaring the numerator. Squaring the first term, I will get sine squared x. Squaring the last term, 1 squared is 1. For the center term, it is always 2 times the first term times the second term with the same sign in the center. So sine x times 1 is sine x all over cos squared x. Notice from this point you have no clue on how to continue because the step that you followed was an incorrect move. The person started to simplify. Now if you look on the right hand side, this is why I say proving something is easier. All you must do is focus on the right hand side. So if you take away your focus from the right hand side, you will tend to go in the wrong direction when solving this thing. Notice on the numerator on the right hand side, we need 1 plus sine x. Can you see the direction in which we went? We will never get 1 plus sine x. Notice on the numerator above, one step above, we already have that. It's just written in the reverse order, which means you should rather expand the bracket in the numerator. Right, notice we switched around the 1 and the sine x so we can make it look like that on the top, on the right hand side. So anything squared is itself repeated multiplication, right? So at the bottom we have cos squared x, which will be an identity. Cos squared x plus sine squared x is equal to 1. Manipulate the formula, So we have cos squared x, because cos squared x is in our numerator above. We can then substitute 1 plus sine squared x for where cos squared x is. The denominator 1 plus sine squared x, notice that that is perfect. Notice that that is perfect squares. Please correct me there. I wrote a plus instead of a minus. Okay, so that is the difference of perfect squares. So, square root the first term, square root the last term. With the difference of squares, one must be minus, the other bracket must be plus. Right, let's write in the numerator as it stands. Notice in this question it's all multiplication, which means we can cancel a numerator with a denominator if it's the same. If we do that, notice the left hand side is equal to the right hand side. There we have it. Okay, in the next example, we need to prove that all on the left hand side is equal to 1. This is a very simple one. Pause the video, try it out. Right, a tip for you, remember to use these identities here. These are the identities to use. Okay, substitute them and solve. Okay, they're now substituted. Notice we got 1 over cos x squared x. What will that give us in a nutshell? Isn't that a reciprocal function? That will give us sine squared x. And 1 over secant squared x will give us cos squared x. And if you know your identities, sine squared x plus cos squared x is equal to 1. The left hand side is equal to the right hand side.